Hello, everyone. How's it going? Welcome to the penultimate day of Global Hack Week. I think it's penultimate. Depending on your time zone, it could be the ultimate day. But, anyways, welcome to part 5 of Music on the Web. How's everyone doing? I have shared the link to register for this session in the chat. Let me know if you all have it, or actually let me go ahead and share it once again. Thank you everyone for joining. Whoever was able to make it today for session 5, followed by session 6 right after this one. Okay, so actually, without any further ado, because I started the stream a bit early so that you all could join, and I also shared the code base, the registration link, and everything so that you all have all the resources that are needed to get started with this project. Okay, so for folks who are joining me for the very first time for session 5 directly, welcome. Also, think you're a bit late, but that's okay. Uh, it's not a problem. What are we doing? Well, and who am I? And what is this about? Let's dive quickly into it. And if you have any questions at any point, feel free to put them in the chat. I will be monitoring the chat. Like I got another device on my left here so that I can keep looking at any chat questions. But sometimes I may miss them, and that's okay because I will get back to them eventually. Okay. So first of all, once again, welcome all. My name is Utkarsh, but I prefer to go by UT because that's how everyone knows me in MLH, at work, everywhere. Okay, and I'm a coach at Major League Hacking. I have been streaming for quite some time. There are at least minimum of 80 videos out there with my face on it and my name on it in Global Hack Week. Okay, so yeah, as you can assume, I've been streaming for a long time, uh, maybe 2 years now if I think about it. Okay, now for this beginners week, I wanted to build a project called which would be a clone of this Songmaker app. If you are not aware of it, let me share the link in the chat. Yes, uh, don't worry, I'm giving a recap right now. So for this beginners week of Global Hack Week, I wanted to basically build a clone of this Songmaker application using React. But when I started the stream, the first stream, I thought let's quickly build the same application in JavaScript and then we'll move to React. And I realized that not everyone is well versed with JavaScript. I had an audience which were beginners, and I wanted to cater to beginners because, well, it's beginners week. So we built the project in pure JavaScript, which we have not completed yet. The project can be found on my GitHub. The link is going to be in the chat. So we are building the clone of it, not with all the features, of course, bits and pieces of the features. Example, let's say we'll have grids, of course, we'll have a play, we'll have a way to choose some options and then play them. Okay. We can choose the tempo, which is nothing but how fast or slow the beats would go and stuff like that. So we are building this project using plain HTML, CSS, and raw JavaScript. And it is not completed yet. So, and at the end of session 4, we had reached somewhat at this point. Okay, so what we had was a grid, which I know doesn't sound much, but the I think over in the last 4 sessions, whoever had joined, they, and if they were a beginner, I think it definitely helped them, in my humble opinion, because we went through every bit and piece of, okay, what is this thing, what is, let's say, an array, how do you use some JavaScript APIs to work with those arrays, how do you make this dynamic, how do you make this whole grid dynamic. And we had ended up with like this part where you could choose some things and like choose some boxes, and now we are left with actually implementing the play button option. So when we click on the play button, it should, play this. We talked about the whole sound waves and more like waves in general. We talked about these two buttons, which we have not implemented, and so on and so forth. So we have done quite a bit. Now in session 5, which is like right now, and session 6, which is right after this one, both of them 2 hours each, we will try and complete this project. Okay, and if the time permits, I will tell you what else we could do to improve this project. Okay, so we'll talk about some additional extra features. Okay, now before we get into development of this project, I want to give you all a quick walkthrough so that folks who are joining for the very first time, they can go over the project, understand what am I even talking about. Okay, let's do it. So what we have a very simple HTML. The HTML is basically what we see here. We have divide, like we talked about a lot about, how to structure an HTML, what is the head part, what is the body part. And in the body, we have a main with an ID app. And in that, we talked about what is the header, the first section and the second section. So we have divided our page into like 3 parts, I would say. There is the header part, there is section 1, which is all the controls. So our play button, pause button, or stop button, whatever we call it, our tempo as an input, the sound wave that we'll select, like are we playing a sine wave or are we playing a square wave. We'll talk about, you'll notice the difference once we actually implement this, our clear button and a randomize button. So all these buttons are in our HTML. Then we have section 2, which is the grid. This was the most dynamic part of our application, because if we go to the HTML of it, we see that the section 2 is just this much. Okay, it's only these bits and pieces where we say section 2 as a comment, and then we create a section with an ID grid, a class grid, a role grid, and area label as notes grid, and we close the section. But if I go to my browser and I check it out, I see that actually it also has a nested div inside it. That div has 2 other nested divs inside it. Then we have this whole labels left side and the spacer. Then we have the right side where the actual grid is. Then which is divided into top and bottom parts, where the top part is the ruler, or basically our notes. The bottom part is actually the grid. So all of this came from our JavaScript. Okay, so the next bit that I want to go over with you all is the JavaScript part. Okay, so in the JavaScript part, what we have is nothing but a very simple rows, which is C3, B2, like all these are rows, and our columns, which goes from 1 to 16 here. Okay. Cool. So we have the rows and we have the columns. Now, in the rows part, that is the total number of nodes that we have, the horizontal pitches or the nodes. and the columns have the vertical time steps or the beats. Okay, we talked about what it is by looking at this very nice, very easy to understand scientific pitch notation, where if you look at a piano, what we are what we have in our notes is nothing but our the C3, B2, A2, G2, F2, E2, D2, C2. So we have it in a descending order, top note to, like, less, where 3 and 2, these refer to octaves. You can read more about it here. So, like, you have, let's say, you can think of it as the start, and as and when it increases, okay, you are going in a way louder and louder. Okay, think of it that ways, that you are going louder and louder. So we are focusing on the third octave, like the first key, let's say, of the third octave and the second octave in our notes. I've also added some comments for everything that we have. Then we created a function of an element. So what did we do? We tried to select, uh, as you may have noticed, we had one section in our HTML which was just this much, and I wanted to enrich it using JavaScript. So the way we did it is by choosing this section in using JavaScript. So the way you do it is you would do document dot get element by ID, and that element has the ID of a grid. And if I hit enter, there we go. So this gives us a reference. By doing this in JavaScript, we get a reference to this HTML of section, right? So that's what we tried to do here somewhere. Yeah, there we go. We tried to get a reference to that grid using get element by ID, where the IDs are on in HTML are supposed to be unique. Okay, so we did that. We got a reference, and then we called this function render grid. This was not a function initially. We created it a function towards the end of session 4. So if you want to read more about what is function, how, like, I kind of gave not gave went into a lot more details about, okay, what is a function, how do you call it, what are different types of returns, console logs, stuff like that. Okay, so yeah, we created it as a function. Now in this function render grid, what we do is we actually render the interactive grid. Now inside that grid, this document.get element by ID grid, I assign it to this variable grid, and I want to append things to it. So we started with, like, okay, if I have to do this thing, document.get element by ID, again and again and again, and then also append a class name to it again and again and again, we were like, we could be smarter, and we decided to use functions. So we created a function el, which is nothing but creating an element and appending it to something. So we talked about, okay, this is how we can create a new element on the page. Let's quickly see it. So document dot create element. Let's first get a reference to the grid itself. So I'm going to say my grid equals to document.get element by ID grid. So if I print my grid, it should give me reference to this whole section. Now in this grid, okay, right below this grid, I want to add my name. So I'm going to create a document dot create element, which will allow me to create a HTML element on the page. So I'm going to say it's going to be a h1 element. Now for that h1 element, I'm going to give it some text content, which would be, let's say, GHW MLH uh, web on, okay, song maker. Okay. And now I can basically take my grid and append a child to it, which would be add my name. And as soon as I do that, as you can see, it now shows GHW MLH dash song dash maker. And how did this happen? This happened because we first got a reference to this section, then we created a new HTML element, we gave it some text content, and then to this grid element, we added a child. How does this look in the elements tab? There's my section 2 whose reference we got, and there is my h1 with some text content. Now I can keep changing the text content of this. So let's say I change the text content to good evening, and there we go, gets applied, right? So now I can keep changing the text content of this because I hold a reference to that element. Okay, cool. So that's about it. What else? So we saw that we can create an element. Oh, also the class. So I can also give it a class name property. So currently, take a look at the h1. It does not have any class equals to something. So we can do that. I can say add my name dot class name equals to my name class. And as I do that, you don't see a difference here, but if you go into the HTML in the elements tab, you see now it has a class. Now on this class, we could use CSS to style it, or even better, I can do some inline styling by doing like dot style dot, let's say, the color, the text color, I want it to be green. And as I do that, there we go. The text is now green in color. I can make it, let's say, purple. And there we go. So we used, so this is how you can use JavaScript to kind of create elements, change their styles, change the content, and do a bunch of stuff. And that's what we actually focused on doing when we uh, built this project. Now, what you saw right now in the console, whatever I did, that is what this function does. It also does one extra thing. Apart from adding just the class name, if provided an ID, it will also add that ID. And then it returns that HTML element. Okay. So we created this function because we were doing some repetitive task of first creating an element, then adding a class name, then adding an ID, then appending it to something else. And we were like, you know what, we could be smart, and that's why we created a function. So we did that. Then in the render grid, so that is why everywhere you will see this thing where we do el and then pass it some parameters. So what will happen in this case, when we pass this parameter, it will create a div, it will give it a class name of grid layout, and it will give it an ID of grid dash layout dash 1. So if our JavaScript is running properly, we should see a div with a class of grid layout and ID of grid layout 1. Then we went on to create left side, right side, rulers, stuff like that. Then we, went into a bit more of JavaScript and understood, okay, what are like, how can we loop over an array? We spent some time there. Uh, Oh, the beat numbers, that was also something like we focused on, like using, let's say, for loop, how we can loop over certain things, how can we create these grids where we loop over the rows as well as the columns and give them some unique IDs or unique positions. So we focused on that. I added more and more comments explaining what is happening. Okay, we also created our variable to hold the grid state. Actually, I can give this a type. Okay, it's going to be a boolean. It's an array of an array. uh yeah, so we've focused on that, like how do we keep a reference to if a box is selected or unselected, how do we hold a reference to that? We decided to do that by very simply making keeping a track of false and true values. Okay, so if initially all the grids are unchecked, so which means all the values are false, as a user clicks on one of the boxes, we change its value from false to true, and we also add a class active. So let's focus on one of these buttons that we created. So if I click on it, the active goes away. Click on this, active goes away, goes away, goes away. I click on it again, it adds an extra class of active. Now all these, like the colors, these are coming from our CSS file. So in our CSS file, we have like if our CSS finds a background color, or if it finds this class name, this CSS class name, then it will give it a background color and a border color. Okay, so we focused on that, and also the value changes, not just adding active or like not adding active. It also changes the value by this line where we toggle the state, where if it is false it becomes true, and then if it is true it becomes false, thanks to this exclamation mark right outside, which is the not operator. We discussed about that. Then we discussed about, the whole click event listener, because we need to do this when we click on something. So we talked about what are event listeners, how they work, stuff like that, and our functions. And finally we appended this uh, as a child to everything. Uh, so the grid inner is a child of grid right side. Grid right side itself is a child of grid layout, and grid layout is a child of the container, where container is nothing but the whole HTML element. So we append the entire grid layout to the container. Then we are calling the function here, and this is also wrapped inside a main function, which is called here. Okay, so that's a quick overview of the whole project. Now there is a question, where is the code to this project? Let me share that quickly. Now, how do you work with this project? Or more like, if you want to follow along right now, how do you do it? Step one, I would say, is please fork this project. As you can see, there are like 8 people who have already forked this project. So please create a fork of this project. What that will do is it will create a copy of this project on your GitHub user. Once you have done that, you have two options. If you have a local development setup, you can clone your version, okay, the one that is on your user, clone that by doing like, copying this URL, going onto your machine, going onto your terminal or CMD, uh, and typing git clone and this URL. Now, I'm assuming, like, if you're doing it on your machine, the assumption is that you have Git installed, you have Node.js installed, and you have a text editor, like, let's say, VS Code, which is what I'm using. If you don't want to do all of that and you still want to follow along, the other option is code spaces. You can use code spaces to have a VS Code on the web. You won't have to worry about uh, anything, as in like installing Node.js, installing Git, nothing, no whatsoever. Everything will be available to you on cloud. But this is a very big disclaimer: code spaces is not free. It is free up until some extent, but after you breach that limit, it will be paid. So please use code spaces on your own accord. Also, please ensure that whenever you are done with your project, you shut down the code space. Okay, so code spaces is nothing but basically VS Code on cloud. Okay, so that's a quick overview, that's a project, and that's how you can work alongside with me. Any questions, anyone, before we start developing? Also take a quick look at Discord, see if there's anyone who's put a question there. No, you don't have to do anything more. Like, it's not required. You can if you want to, but it's not a requirement to do more on this project. And yeah, as in like, if you want to follow along, please do. This is more like a learning project, I would say. So you don't have to, yeah, go the extra mile. But I would love to see if you want to. Okay, so if you build something extra, share it on the Discord chat of Major League Hacking, and I'd love to see it. Love to see what everyone's been working on, stuff like that. No worries. Welcome. Okay, so now I'm going to assume that there are no further questions. Let's do this. Okay, I'm going to move over to the VS Code, and I would keep going on and off the screen, specifically because I want to give you like basically more space here. Okay, one last thing that I want to do is, while we do, create a sell button. Our sell button is nothing but this sell button. Oh, also, how do you run this project? So for that, I am using a live server, one of the extensions. So once you install it, it will be visible on bottom right here as go live. You can click on that go live for index HTML. So go to your index HTML, click on go live, and you will see what I am checking, like I am seeing. Okay. So do that, and yeah, that's it. Okay. One last thing that I want to do here very quickly is smooth things a bit around. So I'm going to move this line. So we create a cell, we add a event listener to that, and then finally I want to append the cell to the grid. Why? Just because. Okay, so the next bits that I want to focus on is access to the grid itself. I'm going to go over to my main function. Now, in this main function, our main function, as I said, is the main entry point to this project. So we get a reference to the grid by doing document.get element by id grid, assign it to grid, and instead of calling it grid, let's call it grid container. Some minimal name changes so that when I say grid, you know what I'm talking about. When I say grid container, what I'm talking about, so on and so forth. So grid container is basically nothing but access to that particular section which had the ID of grid, and we render the grid. But before this, let's do a very quick check. If not grid container, which means that suppose there is no section here, then in that case, we should quickly just return from this function. Also, let's add a console dot error grid element missing. So now this is a very helpful error message on the console. Let's check it out. Currently, if I right click, inspect, go to the console, there is no error. But if this grid example does not exist, let's say I change this grid ID, in that case, I will not see anything and I will have this error message on my console saying grid element missing. So now this helps to ensure that the code is not broken. We have taken care of all the possibilities, or like all the problems that could arise. Okay, cool. Next, so now let's go over to our main function, and I've taken care that there's definitely a grid container, and this is where we build the grid UI. Okay, next is access to controls. So on the top, we have these controls, which is play, tempo, sound, uh, clear, randomize, stuff like that. Okay, I want to get access to those controls. How do we do that? Very simply, I'm pretty sure I've added an ID to all of them. So if I go over to my, let's say, section one, the first section, I have button with ID play. I have a input with ID tempo. I have a select drop down with an ID of wave select. I have a button with ID clear button, and I have a button with ID random button BTN. Okay. So let's get access to those controls. So I'm going to say const play button equals to document dot get element by ID, and it has an ID of just play. Next is tempo input. I can do document dot get element by ID. I think I called it tempo. Yep. Input with ID tempo. Next is const clear button equals to document dot get element by ID. What is the clear button called? I think it's clear BTN. Yep. const random button. It's not like random button because, well, it randomized button, more like a randomize button. That one is random btn, and I'll go in order of how they are noted listed down. So play is first, next is input. The third one is this wave select. So I'm going to do that. Const wave select equals to document dot get element by id wave select. Okay, so we got access to all those controls. Now access to these controls basically means that we can add events on them, we can do whatever we want. Okay, so let's just quickly console.log all these buttons and see what they look like. So it won't be much, it would basically just be the HTML elements. Let's go to the console, and yeah, as I said, it won't be much, it would just be those HTML elements, but it gives a nice understanding of what's happening, right? Okay, okay, cool. Next one is now we are going to get into the sounds part. Okay, so for the sounds part, let's before we get into it, mdn audio context. Let's first read about what is audio context and what does it represent, how it works, and yeah, stuff like that. Okay, so let me also share this with you all in the chat. Okay, cool. Uh, Sorry, I just keep checking for any questions or any messages that I'm getting so that I don't miss anything. Okay, so sorry about that, but I want to ensure that everyone has a proper understanding of what's going on without me getting into like some jargons. At some points, I will use some jargons because I want to also finish this project, right? So, yeah, I may use them. But, anyways, okay. So, audio context. So, this is basically what processes an audio in the browser. Okay. Now, if I have to explain it uh, in a simpler manner, imagine audio context. So, let me come back on screen for this. Okay. So, imagine the audio context as your main. So, in an orchestra, you have a conductor, right? So the person with the stick who goes like, okay, this person is playing or that person is playing, stuff like this and that. So you must have seen it in some movie, some anime, some cartoon, whatever. But you get the idea of, okay, so there are people with different instruments in an orchestra, and then there is this main person who is the director or the conductor, as the official term is, who is managing who is playing and what are they playing, like, and how deep or how fast, or like, yeah, how slow or how fast. And if two of them are going to play together, one of them are going to play together, stuff like that. Okay, so when we start developing, you will see this word audio context. So that is basically your main sound system, the conductor, the director, or the main thing, or the main API, which is going to manipulate any sound that we have. So we cannot actually create a sound. So all those waves that we have created, the sine wave, square wave, triangle wave, saw wave, like, we cannot use any of these unless we have an audio context. Okay, so if you don't have the director or the conductor, you can't do really much. Okay, so we will create a function like ensure audio context, which ensures that this audio context exists and it has a value. So that is the base or the foundation for everything else that we build. So that would be the first thing that we do. Then the next bits that we'll focus on is frequency, oscillators, beats per minute, and stuff like that. So let's get these jargons out of the way before we actually start writing code. So the first thing that I want to talk about is what is the frequency. So a musical note, like we discussed this in not detail, but we touched upon this on our session 1 or session 2, I think, where we said that a low frequency or a high frequency, this is nothing but the sound wave that is vibrating at a specific speed. Okay, so if it is going too fast, too slow, that is what is going to, if there is a wave which is going too fast or it is going too slow, it is going to create some sort of sound. Okay, so if you have a slow moving wave, or let's say a low frequency wave, then we are creating low pitched sound. Think of drums. Okay, so drums, if you like, you do one bang and you have like kind of, so that would be a low frequency. A high frequency would be our fast vibrations, or we would say that the sound is moving very fast. Okay, so what has a high pitch? A high pitch would be like a very uh, sharp tone. Okay, imagine a trumpet or a flute, actually. So these would have a high pitch because they have fast vibration, because you literally are blowing air into those things, right? So it would be like, if it is too slow, air would not move quickly and you will not get the sound. So you actually would use like blow air into a flute or a trumpet quickly, or faster vibrations will occur, and that will create a high pitched sound. Then when we set a frequency, that is what we mean of what sound to play. Okay, so if the frequency is low, then we are going to tell it that, okay, it's a low vibration, it would be more bass. Okay, it will be a low pitch sound, it would be more heavy. Whereas if we set the frequency high of something, we are saying that this would be fast moving, so it would be a high pitch sound. Okay, uh, and by choosing these different kinds of waves, we are technically creating different types of instruments. Okay, the waves are nothing but different kinds of instruments. That is what even on Chrome Music Lab you would see. Okay, these are nothing but different kinds of instruments. Okay, different kinds of waves is equals to different kinds of instruments. Cool. So there's that. And we talked about like sine and square, they would be more like smooth, and then triangle and saw there would be more electronic or buzzy. I don't know what you will call it. And beats per minute, it is basically the measure of speed. Okay, how fast or how slow. So when we write in our code bpm, or the beats per minute, it is nothing but talking about how fast or how slow are we going. So the base that we have set is 120, which is basically medium. If you go like 60 beats per minute, okay, so 120 beats per minute means a you're doing 2 beats in 1 second, right? If you go 60 beats per minute, that means you are doing 1 beat at 1 second, because a minute is 60 seconds, right? So basic math right there. If we go higher, so we can go to 240, let's say. So we are doing 4 beats in 1 second. Okay. So these 16 columns, they represent the beat. So if I go for like, let's say, tempo of 60, we'll do in 1 second, we'll do 1 beat, in 1 beat, 1 beat, 1 beat. Like if we have 60 of these columns, then it would take 1 minute to go from 1 up until 60. Okay. So 1 beat per second. If I go 120 on the tempo, which means like if I have 60 columns, uh, which I can very quickly create thanks to our dynamic programming. We ensure that things are dynamic. There we go. So if I have 60 nodes or 60 columns, and I say that the tempo is going to be 120, okay, 120 in 1 minute. So we'll cover 2 columns or 2 beats every second. So now we are increasing. Okay, it's going to go fast. So and if I increase the tempo to 240, it would go like 4 beats in 1 second. So it would be way faster, right? So yeah, that's what beats per minute represents. So and depending on that slowness or fastness, you get different kinds of sound. And in that, if I change the musical instrument, we'll hear it differently, we'll hear it in a different manner, right? So yeah, that's it actually about all the music knowledge that I have. uh, if there is anything else that we get as we build on this project, if there's any other thing, then we can of course quickly google that bits. Okay, cool. Let's move on to the code part. Okay, cool. Okay, so let's move on to the code part of this one. Trying to see if there is anything else that we'll need. No, where we were here. So we got access to the controls, and now let's focus on the playback state management. We talked about what is state management. It's nothing but basically the values, right? Okay, let's first create our first variable. In this playback state, uh, we'll have audio context, which will initially be null. Okay. Then we'll have let is playing, which will be false. Then we'll have let current column, which would be, let's say, currently the 0th column. Then we'll have uh, timer ID, which would initially be null. And we'll have a base frequency, which I'm going to set to the base frequency of C2. Okay, so what are we doing? All of these ideas came from like Chrome Music Lab. So, oh, let's change this to, okay, cool. So if you choose something and you click on the play button, you see there is this blue highlight thing which basically goes one over, like, one column at a time and plays all the notes in that, plays all the bits or plays all the highlighted boxes in that particular column or in that. Okay, so we step one, we want to check if it is currently playing. If it is playing, then we will pause it. If it is paused, then we'll change the button name to play. So we want to keep a track of it is if it is playing or not. Then we want to know where the current column of our player is. Okay, is it on the like column number 1, is it on column number 2, which column is it on? Then the timer ID, so this will help us keep track depending on the tempo. Okay, so depending on the tempo, and also when we reach the end of this, we want to come back to the start and start again, right? So the timer ID will help us keep track of that. And the base frequency is nothing but what is the initial frequency of all our these notes, okay, these octaves. Okay, you can, or the pitches. How to explain it? Let me think. I think you can find it here, but you can say that every, like, yeah, there we go. So C4 has a frequency of 256 hertz. Okay, A4 has this particular frequency. Hmm. Okay, cool. So similarly, for C2, this is the base frequency of the C2 note. The C note in second octave will have, it has this particular frequency. So we are using that as a base because, as it's said right here, everything else is power of 2. Okay, so we need a base, and then we'll calculate all the other frequencies as power of 2 from that. Okay, so let's go back and, okay, step one, let's first create a function, ensure audio context. So in this function, we will say that if initially there is no audio context, which will be true because initially the audio context is set to null. So if there is no audio context, let's create a new audio context. So we'll do new window dot audio context. Okay, this much. Where did I get that from? Just very simply, by going into this one where it says to initialize a new audio context. Think of it as a new main character, okay, the main character energy. So if you want to initialize a conductor, the director, or whatever you want to call it, the base of all our audio notes that we create, you initialize it as new audio context because this is a class, and we use this constructor to build it. And we can pass it some options as well: latency, hit, sample rate, sync id. Not going to use any of those things. Very simply, new audio context, and we assign it to this variable that we have created, audio context. Oh, so param, and this will be of type here, audio context, and it will be called as audio context. Why does it keep saying any? That is what's annoying me. Ignore it for the time being. We'll fix it later. Okay, so we have created a function which will ensure that there is a new audio context created for that particular window. Okay, now this will not do much other than when I call this function, let's say. So when I call this function, it will assign audio context some value. So now if I, let's say very quickly, console log audio context, okay, that will exist. And you can see what it has as its defaults. So there is a base latency, there is the current time, output latency, sample rate, sync id, the state of it if it is running, or I'm assuming there would be another state of paused, or whatever. If there is an error, what we want to do on state change, on sync change. Not very aware of all of these bits, but very simply now we know that initially audio context would be null, but after we call this function, it would actually, like, initially it would be null, but after we call the function, it will have a value. Okay, so that is our audio context, very created very simply. Next is going to be another function where we do get column duration milliseconds. Okay, ms is milliseconds. So we are going to convert the beats per minute to column duration in milliseconds. Okay, what this means: step one, first let's calculate the beats per minute. Okay, or not even calculate, we need to get it from this tempo input. So let's do that. We can say that it is, if we have a tempo input, it is going to have a value to it. Okay, so it is going to have a value to it. Let's console.log the beats or bpm. Okay, we'll call this function right here. It does not need any parameters, so that should be fine. And as you can see that currently it says 120. If I start increasing this, okay, it does not really play nice, it does not change as I start, like, changing it or doing something with it. But that's fine. If I call it after I have changed something, if I have another function which keeps a track of, okay, call this beats per minute function every time you make a change, then I think I will have the values. But very simply, initially I started with 120 as a value, and it shows. If I change this value to, let's say, 100, as you can see, beats per minute goes to 100. Okay, so it reads the value that we have here. The only interesting bit is that inputs are always in strings, and I want to change it to a number. Okay, I want to ensure that it is a number. So I'm going to do one thing. I'm going to say that parse this as an integer. What should it parse? The tempo input dot value. Okay, so I used a question mark here. So the question mark denotes that maybe the value would not exist. Like, what if it is empty at the beginning? Let me cut that. So if I don't have it, then it becomes nan, not a number. Okay, but if I, let's say, also don't have this bit, okay, it will still keep returning me not a number, saying that there is a value but I'm unable to convert it to an integer. So in that case, if that is the case, I also want to ensure that if there is no value, default it to 120. So now, regardless of what happens, it is going to be always 120 if this value is not provided. So let me add it back. So if that value is provided, I will see it here, and I will also be able to parse it. If that value is not provided, then I'll use this or 120. Okay, so this is suggesting that try the left side first. If this fails, then go for the right hand side as an assignment to this beats per minute value. Okay, and what are we going to do is we are going to return okay, so we are going to return, we'll how many beats per minute. Okay, so we have, if the user is choosing 120 beats per minute and we have, let's say, 60 columns. Okay, and I've also highlighted that after every fourth one I want to do a beat. So imagine if you're playing a musical instrument, you go ting 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 and beat together. So ting 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 drum, ting 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 drum, kind of. Okay, so that is the beat part, if I have to say it. So what are we going to do is, we are going to have 60 seconds. So this will return in milliseconds. Okay, so 60 seconds multiplied by 1 second has 1000 milliseconds. So remember, this is beats per minute. Okay, so 1 minute has 60 seconds, but we need to convert it into milliseconds to ensure that so this will help us calculate how much to wait before we move to the next column. Okay, so 60 seconds into 1000, it would give us 60,000. Then let's say we divide it by how many beats per minute the user has done as an input. So if it is 120, then it will be 120. If it is 60, it would be 60. And then we'll divide it by 4, because as I said, we'll put a beat at every fourth column. Okay, so I think I can simplify this a bit more by just changing this to 60,000. Okay, but let's add a comment. 60,000 is also, did you know you can do underscore on a number, which means like it acts as a comma. So I'm going to say like the 60,000 is basically 60 seconds multiplied by 1000 milliseconds. BPM will be user input of tempo, and 4 is nothing but 4 columns per beat. Okay, so what does this do? This is going to calculate how long we will wait before moving to next column. Okay, so let's do a quick calculation. So if my beats per minute is going to be 120, okay, so I have these many seconds divided by, if beats per minute is 120 and every fourth column will have this beat, then we'll wait 125 milliseconds in every column before we move from this column to the next one. Okay, so that is what this is representing. So if I go to 40, okay, so let's go over and change this to, let's say, 240, then we'll only wait 62.5 milliseconds, okay, milliseconds, before we move to the next column. So if I have a tempo set at 240, it will go quicker. But if I reduce this tempo all the way to 40, okay, let's do a quick calculation. We'll wait 375 milliseconds before we move to the next one. And that is a noticeable difference. Okay, so that is what we are calculating at this point. Okay, how much to wait before we move to the next column. Okay, cool. So so basically what we are trying to say here is, if our tempo increases, okay, if our tempo goes higher, then we are going to wait for a shorter time and the music is going to play faster. Okay, cool. Next bit is going to be another function, get frequency or row, and we give it a row name. Okay, okay, cool. So the next thing is going to be get frequency for row function. Now this get frequency for row function, it is going to convert the rows that we have created. Okay, so we have created these rows C3, B2, A2, G2, F2, E2, D2, and C2. Like if you see this piano and you're playing on a piano, it makes sense as to what it is. Okay, what's happening here, what are we talking about? But from a code perspective, we have not done anything to explain what should happen for each of these rows. So that is what we are going to do here. So for each of these rows, as I said, sound is nothing but a frequency, and a frequency is nothing but a number. Can we do something? Can we write some code? Can we do some calculation which will allow us to, yeah, convert these random like strings, some letters, some numbers, to some kind of sound? Okay, or at least uh yeah, play something. Okay, so let's do that here. So step one is going to be const semitone steps equals to an array of 0, 2, 4, 5, 7, 9, 11, and 12. Okay, next is going to be const step equals to semitone steps of a particular row, or leave it at 0, and we are going to return the base frequency multiplied by math.pow 2 comma the step divided by 12. Okay, now what does this even mean, and where does it come from? Okay, so imagine a piano. Okay, let's only focus on these values here, the second octave and this third octave bit. Okay, let's only focus on that part. Okay, so we have a toy piano. Okay, so we have a toy piano. Sorry, I just again keeping on like replying to any messages or anything that I'm getting. We have a toy piano. Now in that toy piano, imagine that we only have eight, what do you call, eight keys. Yes, eight keys. And if this is my 0, 1, 2, 3, 4, 5, 6, 7. Okay, if this is my 0, this is my 7. We go from low to a bit high, a bit high, a bit high, 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 and up until like when we reach the last one, that would be the extreme high sound. Okay, the base frequency that we set is the 0 or the very low note of C2. I know it is C, like that is the base frequency of C2 because that's what I googled and I found that, hey, this is the base frequency of C2 note. And you can read about this, like, and if you Google, like, what is the base frequency of C2 note, or yeah, okay. So if you Google, like, uh, Western music, uh, mm, what is it called? Do, re, mi, I think. If it opens, still waiting for it to open. I've clicked on it, it's loading. I'm bored. But anyways, you can just search for that Western music notes frequency and the different notes and what they mean. Okay, so based on that is how I got this. So on a C scale, the major C major scale, if I have to calculate, so what is the difference between not the difference, but the smallest of, yeah. So the smallest step difference, let's say, between two pitches in a Western music. Actually, let me write that. So smallest step difference between pitches, ATCHES, in Western music. Okay. So that's how I got this number, like got these numbers. So on a C major scale, semi semitone steps, they represent the difference between two different pitches in a Western music, and this is like these are the numbers that you will get if you just Google long enough. Okay, so that is how I got these numbers. So this is the zero. So this is our first C. Then we go to D as per this one. So C2 to D2. So C2 is our zero. D2 is two pitches, let's say higher. E is from C, it is four pitches higher. F is from C, it is actually five pitches higher, or five semitones higher, or five numbers higher. You can think of it that ways. Then you have G, which is like seven numbers higher from C. Then you have A, which is nine numbers or nine semitones higher from C. Then you have B, which is 11 semitones higher from C. And then you have C3, which is from this C2, okay, second octave, to C3, which is C in third octave. It is 12 semitones higher. Okay. I know it sounds much, but all it is these are some default numbers that you can just Google and find out. So from there, I got these semitones. Now, what I'm saying or doing here is in semitone steps, if I like, how many of these do I have? How many rows do I have? I have one, two, three, four, five, six, seven, 8 rows. Okay, so how many numbers do I have here? One, two, three, four, five, six, seven, and 8 numbers. Depending on the row, if you are talking about the zeroth row here, then I am focusing on that, let's say C3. Actually, I should have done it in reverse. C2 should have been on the top and C3 should have been on the bottom. Okay, so there is one teeny tiny mistake here. C2 and C3, they are like on the reverse sides. Okay, so I will need to do, actually leave it be. You can switch it around and see the difference. Like mathematically, it won't make a difference, but logically, it will. Okay, so you talk about the first row that you give, let's say the C3, it will set the base frequency of it or the semitone step as 0. Then you go one row higher and that would be 2. Then one row higher, that would be 4. So A2 would be like, let's say 4, so on and so forth. And so now that we have assigned all of them their position from like C3, if you consider that as your base, we now know like these numbers represent how far is the difference, or this musical note, how high it is from the base here. So we have we got all the steps for each of those notes in this line, and now we are calculating, or for every row it will return me the frequency. The base frequency I've already found out, which is the base frequency for a C2 note. Okay, now see, that is why I'm saying like this is wrong, because well, if this is the base frequency of my C2 note, then why am I assigning it to C3? So actually, I should probably move it around. Or okay, leave it be for the time being. Base frequency for a C2 note, like I can basically start playing from bottom up then, right? I don't have to play from top down. I can play from bottom up. I'll leave it as is and I'll play from bottom up. That would be simple. So base frequency of C2 note and multiply it. So this is, you can think of it as the formula for music intervals, and that comes from when I googled well, when I googled last time about the musical notes. It said that they have a difference of, like, they're squared, right? Squared of something. So that is how I got this particular formula. And every time, so this formula, what it does is we go up one octave, it doubles the frequency. One octave is technically made of 12 semitones. Uh, so, what this will calculate is for the row 0, it will have the base frequency, which will be 65.41. For the next one, which is technically should be D2, okay. So for D2, this value will be 65. So let's say for D2, this value would be 65.41 multiplied by math dot power of 2. So math dot power, which means that it calculates the power at 2, and then the step, this is going to be at the step will return me this value 2 here. So 2 divided by 12. So this is what it will give me. And let's calculate this value. So this will give me 73.42 hertz. So D2 will have the value as 73.42 hertz. Then if I use the same formula, I'm going to calculate math.power, which is like square it. But what is the step for E2, let's say? 4, right? So then I will do 4 by 12 and it will tell me that E2 is going to be at 82.41 hertz. Okay. So that's how, like, these numbers, that is how it is going to work. We don't have to, like, one last thing that I want to make a note of here, you don't have to know about this, like why this will sound good together or why this formula works. Let's just say, like, this is where I say I'm telling you it works, because when I googled, I found that okay, this is the exact formula which actually will work, does work. It is the mathematical combination which someone figured out a long time back, and we just have to use it. Okay, so this is the moment where I say I am telling you that it works, just listen. Kind of. Okay, so I won't be able to explain deep into why these sounds work, why humans would love this sound, or why this note works, blah blah blah. Let's just say at this point, these notes at these frequencies just work. Okay, cool. So that's enough about me talking about notes. I wanted to calculate or show what that calculation is. I think I've tried my best to explain what these frequency for each row means and what it calculates. All it does, it gives us the frequency of a particular node at a particular step, okay, at a particular point in our row. So each of these numbers now have some values. They're not just some random numbers, they have some assigned values. Okay. Uh, cool. Next one is going to be another function, which is play note at. It will take in two parameters, row and time. Okay, so what is this going to do? So play note at, this is going to actually do like, let's say, a beep sound. Okay, so if I remove these from Google Song Maker and I actually remove this as well, play here. So it played that note at that particular row and at some particular time. Okay, so play note at is basically very simply going to make a single sound. Okay, okay, a single beep sound, let's say in this case, or a simple ting sound or some sort of sound, depending on the row it is at. Because if I have a note at this versus this row, there is a difference. So at a particular row, and also depending on the time that we are, uh, okay, how far ahead and stuff. Yeah, this function is going to calculate that part. So step one, we first need to get the frequency of the note in that particular row. So we have a function for it where we can pass it the row number. Okay, so play note at will be called with some row and the time. When we go inside that function, we'll first get the frequency for that particular row. So that frequency will be some number. So if it is the 0th one, it will tell me, oh, the frequency of this is going to be 65.41. Okay, then remember the audio context. So audio context has something called as an oscillator. Okay, so this oscillator, you can think of the oscillator as the one that is going to create the sound. Okay, so I got this from, like, if you see, literally this is what we are going to do in our code. We have already created a new audio context. I call it audio context. They call in their example audio CTX. Then we are going to create an oscillator node. Oscillator node is nothing but, you can think of it, the thing that will make the sound. Okay, this is like a buzzer or a ting, or like, basically this is the element, or this is the instrument. Okay, this is the machine that will make the sound. So that is what we are doing here. Const oscillator equals to the audio context that we had created. We do a dot create oscillator on it. Then depending on the sound wave you choose, which is sine wave or square wave or triangle wave or saw wave, we literally will do exactly what they say. We'll set the type depending on what the user has chosen, and then we'll of course do the whole frequency part, where we'll do oscillator dot frequency dot value. Then yeah, like, literally we'll follow this in a way. Okay, you can try this out. It's cool. I did not see this the other day. I did not try that example. But if you go to their website, the information website, yes, so this is what we are going to do: oscillator, gain, connect, and blah 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 blah. Oh, also there is another thing. So when we create an audio context, we should do window.audio context or window.webkit audio context. I think WebKit would be Safari mostly. Pretty sure. So I can do that actually. So here we do window.audio context. I can say call this function with window.audio context or window.web audio context, WebKit audio context. I got this from their documentations, not documentation, but one of the examples. I'm going to copy this part, remove it for the time being, and say add this. Add it as a to do. See this particular line. Okay, this is where we are going to get it from and understand. Perfect. Okay, so oscillator, this is the thing that will make the noise, make the sound. Then we'll have another thing called as gain node. So the gain node is nothing but, so we are going to do create gain. Okay. So as it says, it is literally going to control the overall gain or the volume of the audio graph. So gain node is nothing but the volume knob, literally. Okay. That the description says that. Uh, they don't show it here, but in their web audio example, you can see that they do it. Const gain node equals to audio context dot create gain. Okay, now the waveform part. So we are going to say the waveform is equal to whatever the user has selected, wave select, or let's default it to sine wave. I know we have set a default as sine already, but still, good to have a fallback. Now, uh, we can set the oscillator dot type equals to whatever comes back from the waveform. So this would be either a sine or a square or a sawtooth or a triangle. Okay. Next is the frequency. So oscillator dot frequency dot value, that will be set to the frequency that we get for each of the rows. Okay. Then finally, gain node dot gain dot value is going to be 0.001. So we are going to say that we are going to start these values at like kind of very silent, very low noise, very low sound. Okay, that is why we are going like 0.001. And as the time goes, we'll increase these values. So we'll increase this sound as the time goes. So we won't start with like a very huge 100% volume. You can think of it as the volume as 1%, and as the time goes, we'll increase it one by one. 0.1% actually. 0.1% volume. Yes, because if I do 0.1 divide by 100, 0.01, 0.001, okay, 0.1% volume. And then as the time goes, we can increase it. You can also change it to 0.1%, let's say. So like 0.01, which means we start at 1% volume and then we increase. Okay. uh, Next is oscillator.connect, that allows us to connect different pieces. We want to connect the sound, so that is why I'm going to connect it to the gain node, where the gain node has the value, the sound, and uh, the volume and what is the current value of that volume. Dot connect again, so we can connect. As I said, connect allows us to add multiple pieces. So we want to also add the audio context dot destination. Okay, so this is going to help us play the sound in on our speakers. Okay, so that's very simply, that's what it does. That is the one that is allowing us to play the sound on the speaker. Okay, the next bit that I want to add to this is we need to increase the sound as it goes along, right? I'm going to say gain node dot gain set value at time. Okay, so at a particular time, increase the value basically. So start at this, then we'll increase it slowly. So I'm going to copy paste this. So gain node dot gain, and I'm going to say linear ramp to value at time, and we are going to increase it by, let's say, 20% at every millisecond, every second. Okay, okay. Where do I get these things from? You can just read about it right here. So as you can see, once we have connected a gain node, which we did before, initially we start at, let's say, no sound at the current time, and as the time goes by, it automatically keeps on increasing. Okay, so that is what we are exactly doing here. So you can read that documentation. uh, yeah, the next one is going to be exponential name ramp to value. Gain dot exponential ramp to value at time. Can read more about it here. Let me share that one as well. Okay, again, very simply, these are going to again increase it at an exponential rate, or let's say quickly. Linear is going to increase it slowly or the same step at a time. So if, let's say, it increases by 1 point in 1 second, in the second it will also increase by 1 point, then again in the third second it will increase by 1 point, fourth second increase by 1 point. That is linear. And if we talk about exponential, we are basically saying at first second it is 0, then increase it by 2, then increase it by 4, then increase it by 8, then increase by 16, so on and so forth. Okay, and as it says, these are considered more useful when changing frequencies or playback rates than linear ramps, because of the way the human ear works. Okay, So again, I'm not saying anything. I'm just literally looking at the documentation. I'm like, okay, yeah, if they say that this will sound nice, I'm going to assume that it will sound nice. Okay, so we are going to say that initially it would be this one, and then as the time goes by, just keep on increasing it. So attack is this bit here. So at 0.01 second, which is the instant, and then slowly we are doing a decay of the sound, which means at every 0.25 seconds we are uh, going to fade away. Okay, so imagine hitting a drum. So we start, let's say, hitting it slowly, then we increase, and then at some point it increases to, like, let's say, max loudness, and then we start going down or slowly fading away. Okay, so that is what code wise we are doing here. And finally, I'm going to start at a particular time, and oscillator dot stop at whatever is the time plus 0.3 seconds. Perfect. Okay, so start node at, let's say, 0, and then after 0.3 seconds we are going to stop. Cool. Next bit. So next bit is going to be like, we have done a lot of things, but this is not going to show up visually yet. So the next thing that I want to do is show something, do something which will show it visually. Okay. So we are going to highlight the column, yeah, as the user clicks on, let's say, play. So now let's create a function called as highlight. Actually, also let me remove all of these function calls, because we just keep on creating some highlight column. Okay. Now this one will need the column as well as where are we currently highlighting. I'm going to call it on, let's say. Mhm. Okay. So this on represents basically on and off. So if it is on, that means highlight that bit. So if on equals to true, more like, okay, let's say if this on is equal to true, then we are going to highlight it by adding a CSS class. If on is equal to false, we are going to turn off that highlight by just removing the CSS class. So that is this on, that is what it represents. On is turn on or turn off, more like true or false, highlight, no highlight, whatever. Okay. So uh, what I'm trying to say here, or how this will work, is imagine a karaoke machine, let's say. So in karaoke machine, as the song starts playing and as the lyrics come up and as you start singing, it starts unhighlighting or the bits saying that, okay, you have finished saying these words. Okay, kind of. So that is what we are going to do in the highlight. So we'll give it which column you are on and which beats needs to be highlighted, not highlighted, kind of. Okay, so very simply, I'm going to just do const grid inner equals to grid refs dot grid inner. Now this is a problem. We have not defined what is grid refs. Okay. So grid refs will be will need to be created more like. Where will we create it? Here. So render grid, I'm going to say const grid refs equals to render grid container. Okay. So we have a reference to a grid. So that means this render grid should return something. That is why we hold a reference to it. Currently, it is unfortunately not returning anything. So let's make it return some values. So let's go over to our grid, and right here, I'm going to say that this will return three things. First thing it will return is the grid state. The grid state is the array of arrays which stores the on off state, the true and false. It will also return the grid inner, which is the reference to the grid in the DOM, and it will also return the ruler, which will be the reference to the ruler in the DOM. Okay, so this is my ruler and this is my grid inner. You can actually check that out. We have given the same names. Yeah, there we go. This is my ruler, as you can see the highlighted part, and the grid inner is basically these boxes. Okay, so ruler, grid inner. So these two DOM elements are going to be returned from our render function, render grid function, and it will also return the grid state, which will have the value of which boxes are true, which boxes are false. So all of these are false. There is one box, so column number 012 and row number 0, this has the value of true. Everything else has a value of false. Okay, so now we have grid refs, which will return, as you can see, three things. And now we are taking the grid inner, we are grid refs dot grid inner and assigning it to grid inner uh, variable. So now we hold a reference in the same variable name, basically. Ruler, we can again do grid refs dot ruler and assign it to this ruler variable. And we can have, if there is no grid inner, or there is no ruler, so if both of these values don't exist, then simply just return. We can also do some very nice console.error saying grid or ruler reference missing. Okay, so now user will be like, okay, this is the error that I see, what is missing. Okay, perfect. Next step is we will loop over all our rows and we will add a CSS class. Okay, so let's do that. So I'm going to say for let r equals to 0, where r is nothing but my row number. R is less than the total number of rows I have. So if I have 8 of them, then it will be 0 to 7. And on every iteration, we increase the value of r by 1. Const cell index is going to be r into columns plus col. Okay. And const cell is equal to grid inner dot children at that particular cell index. And if there is a cell found, then in that case, cell dot class list, which will give me all the class names, and I want to toggle this playing dash call depending on the value of on or off. Okay, so what is this going to do? Let's say we call this function highlight column with column number 0 and on state as true. Okay, column 0 on state as true. So this function, what this will do is it will start from the 0th row, column number is 0, 0th row, and it will be like, okay, what is the index of this particular box? It will be r, which is 0 multiplied by total number of columns that we have. So 0 into 60 would be 0, plus what is the index that you passed. Okay, what is the column you passed? I passed it 0. So the cell index is going to be at this position 0, right? Like this calculation will give me 0 as the cell index. Now for this particular cell, I want to get a list of all the class names it has. So currently this particular cell has only one class, which is the cell class. But if I click on it, it will have two classes. It will have cell and active. So the class list is going, so for that particular cell, so in grid inner, which I have a reference to, I have a reference to grid inner, uh, thanks to me returning that value from the function. I'm going to say that find all the children of that grid at that particular index. So at 0th index, find all the children it has, and then if there is a cell, then get me the list of it and add or remove this another class name playing dash call depending on the value of on. Okay, so if on is true, then add this playing dash call. If on is false, then remove this playing dash call class from the from this button, let's say from this cell or the button. Okay. Next is which ruler are we playing this on? So that will also be, if we don't have a ruler, then of course we would have returned earlier. So I'm just going to say const ruler cell equals to ruler dot children at that particular column index. Okay, so if you give me 0, I'm basically saying that highlight this one. If you give me 1, highlight this 2. If you give me 2, highlight this 3. Okay, ruler cell refers to these top lines. Now again, if there is a ruler cell, then in that case, simply ruler cell dot class list dot toggle playing dash call depending on depending on the variable on. Okay, perfect. So this is our highlight column done. Let's color this. Okay, let's color this highlight column. I'm going to go over to my styles.css and I'm going to we had a ruler cell dot beat. Right below this, I'm going to do dot ruler cell dot playing dash call, and I'm going to give it an outline of 2 pixel solid and a lighter version of this. Okay, perfect. And we also had a dot cell. So even on this one, I can say dot cell dot playing dash call, give it an outline of 2 pixels solid and same color. We can adjust this color, by the way, if we want. Let's say I want this to be slightly more lighter, maybe more on the yellow side. Okay, let's see how that looks when we actually start calling this function or start playing. We haven't started playing yet, so you won't be able to actually see how it looks. But this is the first bit which will actually, yeah, make a difference. Okay, now we are slowly and steadily moving towards playing parts. Okay, so like how do we play it? What happens? The functions to play it. But if I notice the time, it's nearly been 2 hours. So let me come back on screen. Okay. So it's nearly been 2 hours. I think this is the perfect time to take quick pause before we come back. What I'm going to do is we are going to pause right here. Any questions? As always, as I've told you, please put your questions in the chat if you have any at any point. Right now, if there are no further questions, I think I'm going to take this opportunity and I'm going to ask you for feedback. So if you go over to this feedback form, so initially when I had started these sessions, I only had 4 of them, but I realized that I won't be able to finish everything. Uh, so I got part 5 and part 6, but I don't think they have been added. So unfortunately, like just ignore giving feedback for this. I thought they are added, but they are not yet. And that's okay. Your feedback from the past 4 sessions are helpful enough, anyways. For part 5 and part 6, if you have any feedback, you can give them to me in the chat right now. Any sort of constructive criticism is most welcome. Uh, yeah, that's it from me. And okay, what else? Let's take a quick break. Let's take a 15-minute break. We'll come back after 15 minutes and we'll continue building this. We are nearly there. Uh, I say nearly because I think what we have to start a playback, we have to not start a playback, but let's say we need to write a function which will allow us to click on this play button and it will start the playing. It will also change it to stop the playing. So those are 2 buttons and just adding a bunch of event listeners. That's it actually. Yeah. So we would be actually done quicker and then we can just play around with this by creating different types of beats. We can also look into uh, what other functionalities could be added. So if I want to add a bit more things to it, what I could add, what could I not add, stuff like that. Okay. So let's take a quick break and we'll be back in 15 minutes. I'll start the stream, but I won't be joining it up until like next 15 minutes. Any questions, anyone? Okay. Going to take the silence as golden and we'll be back. But before we go, let me actually push everything that we have done so far so that you have the latest code that I have on my machine. This was session 5. Start with audio context and git push. So now you should have one extra commit here, 12 commits. Yep. And in these 12 commits, you can find the whole of the project. So there we go. The latest commit has been pushed. And now let me end this session and we'll be back in 15 minutes to continue building this. Last 3 or 4 functions and we'll be done. Okay. So don't worry about it. Cheers, everyone. Bye bye.